Suppose that we have found the values of the options at n j for all n at some time step j. And we want to proceed in order to find the option value at time j plus 1 at the next time step. Actually, that's what we're doing in our finite difference schemes. We're starting from j equals 0. We know the initial condition, and we want to get, using that values, we want to get the value of the option at the next time step. Then, using the option values at this time step, we want to go further and calculate the values of the option at the next time step, and so on and so forth. So, considering that we already know these ones, so how can we implement the possibility of early exercise in our finite difference representation whenever we have, therefore, these free boundaries, which could be either in American options, the Bermudian options. So how can we implement in our finite difference schemes, any of the finite difference schemes that we have already developed before, how can we implement here the possibility of early exercise? So the key thing here is that in order to avoid arbitrage, then we have to take into account that the price of the option has to be always higher or equal than the payoff. That can be considered that this payoff could also depend on time in the case we have the possibility of early exercise at specific dates, for as the case of the Bermudian options. So how can we do that? That's going to be the key in the following way. So we don't have to worry about whether or not we have violated the option constraint we have mentioned before until you have found the option values, these ones for all n. So you use the finite difference representation in order to calculate the option values the next time step in the usual way. So next, and that's the key thing now, let's check whether the new option values of these ones are greater or less than the payoff. So you have to check if this is verified or not. And if they are less than the payoff, okay, then we have arbitrage, and it can happen. So we cannot allow that to happen. We cannot allow that to happen. So at every value of n for which the option value has allowed arbitrage, we have to replace that with the value of the payoff at the asset value. And this is all. This is what we have to do. Whenever we are calculating that, we have to check if this is verified. And if this is verified, it's okay. If it's not verified, we have to replace the one we have calculated with the payoff. This is what we have to do. And the process of checking that, for example, if it's an American option, we have to do this check at any time. If this is a Bermudian option where it's given to you the possibility of early exercise at specific dates, we have to check it at that specific dates, just at that specific dates. And that calculating that and going from the initial value to the next and next and next step, then you can have the possibility of having the option value, the price of the option value, when the contract is signed, for example. So that's as simple as this one. Whenever you are calculating the new ones using any of the finite difference schemes that we have developed before, then you have to check if these ones are higher or equal than the payoff at the specific dates when you have the possibility of early exercise.